Unmanned aircraft are pretty much like standard aircraft that are flying today, although they range from very small up to very large aircraft. But what we're trying to do is take the pilot out of the cockpit and move that down to the ground. So normally there's wires and other cables connecting the pilot to the aircraft. Now we're actually taking that cockpit, putting it on the ground, and we're flying that with a wireless system. So it's really like a fly-by-wireless type of system that we have flying the aircraft now. And so that communications link, which is what I'm developing, has to be very reliable. I mean, just as reliable as those wires that we're connecting it on board the aircraft.
Because the FAA has stringent rules in place about flying in the NAS, the communications team at Glenn is using a surrogate aircraft to help with the tests. Although this T-34 aircraft can be flown from the ground like an unmanned aircraft, there is in fact a pilot sitting inside the cockpit to monitor the flight during this initial testing phase. If you look at unmanned aerial vehicles of today, one of the biggest concerns comes from the fact that they cannot sense and avoid oncoming traffic autonomously, which clearly represents a significant mid-air collision hazard to other aircraft operating in the same airspace. We travel from destination to destination with little thought of all the people, equipment, and regulations put in place to make our national airspace system the safest in the world. Airports, air traffic controllers, towers, communication systems, maintenance crews, and thousands of other moving pieces, along with regulations, are all key elements that allow for relatively smooth and safe operations for the nearly 50,000 flights that take off and land in the U.S. every day. Our National Airspace System, or NAS, is incredibly robust, and in fact works so well because everyone who works within the system understands their role and the procedures that have to be laid out. But when you have a system that works so well and is so vitally important, the idea of making fundamental system-wide change can be daunting. And one of the biggest changes that will be confronting the NAS shortly is the inclusion of unmanned aircraft systems, or UASs. The FAA has strict rules outlining all aspects of piloted flight, but with no pilot inside a craft, changes will need to be made to make sure these systems are as safe and robust as possible.
So with us using manned aircraft, we can fly anywhere in the National Airspace System where that aircraft normally operates, and that allows us to test in a realistic environment where we expect unmanned aircraft to actually be flying in the future, rather than being restricted to portions of the desert or something where we may not see a lot of unmanned aircraft flying in the future. We'll be integrating the multiple technologies from the UAS project as a whole together and flying those all as one mission. So there'll be a real pilot at the ground control station developed for this project, as well as my radio link, and then algorithms on board the aircraft for the separation assurance portion of the test. So all of that in concert lets us fly the aircraft, because the aircraft will be in a surrogate type configuration, so the commands from the ground control station will actually be maneuvering the aircraft. So in that, it's a full end-to-end test in a realistic environment. The testing we're doing is helping enable a whole new industry for unmanned aircraft, because without this, civilian aircraft will not be able to fly in the National Airspace System.
Their plan is to focus on 4 major technical barriers to make this transition possible. These 4 include sense and avoid, command and control, human systems integration, and integrated test and evaluation. The sense and avoid challenge is focused mainly on the see and avoid problems UAVs have, because there is no pilot in the cockpit. Technology will need to be developed that will, in essence, replace the pilot's eyes with incredibly accurate radar, helping UAV pilots on the ground avoid any nearby aircraft. The command and control challenge will develop a new radio system that will be integrated into the NAS, allowing for reliable and secure communications. The human systems integration challenge is essentially a human factors challenge that will help configure uniform ground control systems and displays to enable ground station pilots to work effectively. And the Integrated Test and Evaluation Challenge will provide a relevant environment, which will allow researchers to integrate different components of the system and test them in a virtual environment, then into real test flights. One of the biggest challenges facing the integration of unmanned vehicles in the NAS is separation assurance, or sense and avoid. Understanding these variables and developing the automation to help pilots make the proper decisions while navigating is challenging. Part of this challenge comes in working through integration issues with air traffic control, pilots in the air, and UAS pilots on the ground. With that in mind, the NASA Langley team has put together sophisticated testing environments, which will allow pilots, air traffic controllers, and researchers to work collaboratively in the confines of the Air Traffic Operations Lab, or ATOL. This team is coming up with procedures for pilots from unmanned stations to communicate and interact in the most effective way with air traffic control and other piloted aircraft. Although the ATOL is physically located at NASA Langley Research Center, a component of this work is also being handled by a team at NASA Ames, located in California's famed Silicon Valley. Here, the UAS team is working on both sense and avoid and human system integration.
My area is human systems integration, and so I work on the ground control station where the pilot or the operator sits to control the UAV. And our work with integration in the NAS is really trying to understand what the minimum displays are, what the information requirements are for that operator to safely operate in the national airspace. And so we've been doing work with the FAA, with RTCA, Special Committee 228, to help develop the guidelines for what the minimum information requirements are for UAV operators to fly in the NAS. We're really primarily integrating technologies that exist today and looking how that they come together in an integrated system to be able to address this need. For example, we're taking onboard radars integrated with other surveillance systems to be able to ensure that the operators can perform see and avoid functions that are currently done visually by manned aircraft. And so it's primarily an integration of existing technologies and developing the requirements and testing those requirements to ensure that the UAVs can safely fly in the NAS.
Just a few hours down the road from NASA Ames, the culmination of much of this integration happens here at NASA's Armstrong Flight Research Center. Since the earliest days of flight, this lake bed in the high desert has been used to test virtually every type of aircraft imaginable. This storied research center is where much of the flight testing for the UAS integration into the NAS will take place. The final challenge is IT&E. Here is NASA Armstrong's Sam Kim to explain.
IT&E stands for Integrated Test and Evaluation, and that sub-project deals with taking the research that our project is developing, all the software, the algorithms, the procedures, and putting that into a relevant environment. That relevant environment entails simulations that replicates the real world as high fidelity as possible, but then ultimately we need to take that to a flight test environment and to be able to validate the results. As the word integrated entails, right, in IT&E, the integrated test and evaluation, it is an integrated effort to take all the elements of the 4 sub-projects that are part of the US and the NAS project and trying to get those into an integrated environment. So yes, we need to make sure that all the systems play together, and more importantly, that they really replicate the real world as close as possible. So ultimately, like I said, it goes from simulations into flight tests. So the research ground control station you see behind me is one of the manifestations of that capability to integrate things. It is a proof of concept ground control station that embodies all from human factors and some of the self-separation technologies that we're developing. It's embodied in this proof of concept GCS. In this RGCS here, we do bring in pilots. So we actually bring in real UAS pilots. In fact, we've not just used NASA research pilots, but we've also used Air National Guard pilots and been able to have a diverse evaluation of our systems. So yes, we bring the pilots here, they get immersed in the simulation environment, and then we're able to collect meaningful data that says that whether the systems we're designing present the right information, and whether they can assimilate that data quickly and be able to react to the national airspace.
And having these systems that can be just as safe as the manned aircraft, which we have the safest air transportation system in the world. And so as the FAA takes these new technologies, introduces those into unmanned aircraft, and introduces those into the NAS, that safety will not be compromised. We are doing this and making sure that then when the FAA assesses the technologies and assesses any airframe and the avionics that they have or the sensors that they have on board, that those are going to meet the same sort of standards, maybe not the same exact standards, the same sort of standards that they've established for manned aircraft. So safety is always in the back of our mind, and it underpins every decision we make and everything that we do.
The task is definitely daunting. We focus particularly on procedures and standards. So from the procedure side, the FAA has built a very, very safe national airspace system. Accidents essentially don't happen. A lot of the rationale for that is procedural. Our air traffic controllers know what they're doing, they know how to manage their airspace, and bringing UAS into this system changes things. What we're trying to do is help inform procedural development so that the FAA can take our inputs and integrate them into their new air traffic control system as they develop their next-gen infrastructure.
When the integration is complete, many of the so-called dull, dirty, and dangerous missions will be turned over to these UAVs, paving the way for a new, safer way to monitor important tasks. We are not there yet, but it's clear that the UAS challenges that have been laid out are daunting. It is also clear that the brilliant men and women of NASA are rising to the challenge as only NASA can. Thanks to their pioneering work, we will soon have a new type of tool available to humanity that will almost certainly prove to be invaluable by making our world and skies safer and perhaps even better than we ever thought they could be.